So today we have a to the power of b minus b to the power of a equals to 17. A and b are natural numbers. So we're going to solve together. Let's see solution. We can address this equation in different forms, but this negative sign is very valuable to this equation since it can form our distinction. So with this, we can think of the principle of difference of squares. That is, our equation a to the power of b minus b to the power of a is equal to 17. To transform this to the concept of difference of squares, we can consider b to be equals to b over 2 times 2. When 2 cancel out 2, to be left with b, and we're fine. And also a to be equals to a over 2 times 2, so that when 2 cancel out, what is left is a, and a is equals to a, and that's good. So in the place of a, we're going to write this, and in the place of b also, we'll write this. So that the next line becomes a to the power of b over 2 times 2 minus b to the power of a over 2 times 2, and this is equal to 17. But a to the power of m times n also can be written as a to the power of m and times n, or it can be written as a to the power of n times m, and it's all fine. So in the next line, we can therefore write as a to the power of b over 2 to the power of 2 minus b to the power of a over 2 also to the power of 2. This is equal to 17. So if we consider to do a change of variables, then we can say let x be represented as a to the power of b over 2 and y be equals to b to the power of a also over 2. That way, this equation becomes x to the power of 2 minus y to the power of 2 equals to 17. And we are fine. But from algebra, when we have a to the power of 2 minus b to the power of 2, and this is represented as a plus b times a minus b, where a will be equal to x and b will be equal to y. And this is the difference of 2 squared, which is our objective. So since this is in the form of this, we're going to write the equivalent of this in this form, that is x plus y for this times x minus y for this equal to 17. This 17 is a positive number, and we can consider to write 17 as 17 times 1. Also, since AB is a natural number, so x plus y and x minus y must also be a natural number too. That means x plus y is greater than x minus y. So if we agree on this, we can deduct that x plus y is equal to 17 and x minus y is equal to 1, and we are fine. So to solve this simultaneously, we are going to decide to add the two equations so that x plus x will be equal to 2x, and y will cancel out. 17 plus 1, that will be 18. From here, x is equals to 9. But from x plus y equals to 17, 9 plus y will be equal to 17. So that y will be equal to 17 minus 9. And y equivalently will be equals to 8. So the values are x, y equals to 9 and 8. Recall that we agreed that x and y should be represented as this. X is equals to b over 2 and y is equals to b to the power of a over 2. X is 9 is equals to a to the power of b over 2 and y is 8 is equals to b to the power of a over 2. And 9 can be written as 3 to the power of 2 is equals to a to the power of b over 2. And 8 can be transformed as 2 to the power of 3, which is also equals to b to the power of a over 2. Here we can equalize the basis and also the exponent. That is, if we say 3 is equals to a, that means 2 is equals to b over 2. From here, b will be equals to 4. And again here, if we say 2 is equal to b, that also means 3 is equals to a over 2, so that a is equals to 6. So if we write out the pairs, a is equals to 3 and b is equals to 4, a is 3, b is equals to 4, and the second pair, a is equals to 6 and b is 2. A is 6 and b is 2. These are the pairs of possibilities that we are going to replace on the original equation to find the set of solution. That is, to verify the first possibility from our original equation, a to the power of b minus b to the power of a equals to 17, so that a will be 3 and b will be 4. Equation becomes 3 to the power of 4 minus 4 to the power of 3. Will it be equal to 17? If we do this very well, 3 to the power of 4 will be 81 minus 4 to the power of 3, and that is 64. We want to know if this will be equal to 17. This is 81, 64. Carry on here 11, 4 minus 11, that is 7. What is left is 7. 6 minus 7, that is 1. Of course, 17 is equals to 17. So the first pair is verified. Again, the second pair, we have a to the power of b minus a minus b to the power of a. Would it be equal to 17? So we're going to verify a is 6 and b is 2. So this equation becomes 6 to the power of 2 minus 2 to the power of 6. We want to know if this will give us 17. And 6 to the power of 2, that is 36, minus 2 to the power of 6 will give us 64. Will this be equal to 17? If you do this very well, you are going to have a negative sign from this part, and 17 is a positive number. That's to show that the only pairs of solution is 3 and 4. Thank you for staying tuned to the end. Please help us to grow. Subscribe to this channel and hit on the like button so that more persons can have access to this video. See you in our next video. Bye bye.